and welcome to ChefConf 2021 online. Today we'll be joined by Joe Nussbaum, Principal Engineer at Workday. If you've got any questions, drop them in the Zoom Slack below and we'll answer them at the end. Alternatively, you can join the Chef Slack and enter them in the DevRel room there, and we'll answer those again in there at the end. And without further ado, we'll hand over to Joe now. Thanks very much, Joe. Take it away.
Thanks. My name is Joe Nussbaum, and this session is testing hardware cookbooks with Kitchen. I'm a principal engineer at Workday. I'm based in Portland, Oregon, and I'm one of the DevOps Days Portland organizers. I started with Chef back in 2011 with Chef 0A2 on CentOS 5.3. And those were some pretty hairy days. I remember when we made the migration from Chef 0A2 to 094, it was using the Rebel repository. That was the Ruby for Enterprise Linux. And there was a bug in the Ruby implementation. So I had to patch Ruby. And in doing so, the version of Perl that was included on CentOS was too old for Automake to run. So in order to rebuild Ruby, I had to build a new version of Perl just to run Automake to get the new version of Ruby for Perl, for Chef. And so things have come a long ways. I love the Omnibus installation. It makes so much easier. It's just great. I have been around and active in the community for quite a while. I am the author of the Zap Cookbook, and I blog sporadically at nvwls.github.io. That's no vowels with no vowels. And you can tweet me at Joe Nussbaum on Twitter. But that's enough about me. Let's talk about bare metal. Okay, well, not that bare metal, but this, racks and racks of servers. When you peel back the layers of virtualization, all software runs on bare metal. And that bare metal needs to be configured. There are BIOS settings, RAID settings, power configuration, hardware health monitoring, and all this configuration should be codified in cookbooks. And all software should be tested. Cookbooks are software, ergo, cookbooks should be tested. I review a lot of code. Sometimes I will ask, have you tested this edge case? Often the answer is no. The excuse being that they don't have real hardware to test the cookbook. But I need real hardware to test the cookbook. They protest, to which I say, wrong. You may need hardware to validate the configuration, but by the time you're codifying your changes, you should have already validated that config. Since you are writing recipes, the whole point of kitchen testing is to validate the recipe code. Say I have a simple recipe that just installs bash. I could test that bin bash exists and is executable. But at that point, am I testing the package manager or my recipe? Or that the RPM was created with the correct contents? You need to trust the layers below you and just test the code that you are writing. Trust the contents to be correct and just verify the package is installed instead of testing for individual packages or files within the package. Just because the code fails doesn't mean that it is incorrect. Let's take an example of an NFS mount. The recipe enables a mount by adding it to Etsy FS tab and then mounts it if it is not already mounted. And why could this fail? Maybe there's a firewall rule preventing the client from reaching the server. Maybe the server exports the volume, but just not to that client. Maybe the server is down for maintenance. The whole point is that the recipe is correct. The failure has nothing to do with the recipe. Furthermore, there is nothing the recipe could do to fix any of those error conditions, except that it could fail and avoid that failure. Now, I'm not talking about ignore failure. That's ignore failure in my experience is pretty bad because it masks failures that you really want to check out. So we're not talking about ignore failure. But since the mount action is problematic in your test environment, don't do it. So back to the recipe. There are two things that it does that can be tested. It adds an entry to etcfs tab, and it mounts the volume. When it is mounted, the kernel updates proc mounts, and that's actually what InSpec is looking at. So there is persistent state, etcfs tab, and then there is pointance time state, which is the proc mounts. If you look at a client during boot, before NFS is started, the volume is not mounted. Or if the server is down when the client tries to mount, it will fail. However, if you try those operations again in a minute, it may succeed. So the recipe is correct. It just has timing dependencies. And there are different types of testing, lots of different types of testing. There's integration testing, which Kitchen is used for. I mean, the default directory for tests in a cookbook is test/integration, which is trying to answer the question whether the cookbook configured things. You focus on persistent things. In our example, etcfs tab. And then there you have compliance testing. Does this server fulfill its purpose? And you focus on state. And these tests are all about the here and now. While it is great that the volume is an etcfs tab, if it is not mounted, the server cannot serve traffic. So it's really not doing its job. So as I said before, for your test environments, you want to skip the mount since it's not going to succeed. Now, you could do this by special casing Kitchen. I mean, it is ugly, but it works. The recipe does converge. The downside is that you have to modify your source code for each and every mount resource to put the special casing in. Instead of modifying every mount resource and remembering to do so in the future, you can leverage event handlers to modify the behavior. In this example, at the start of the converge, we walk through the resource collection looking for NFS mounts and then skip the mount action. So eventually you start building up a group of these helper functions and fixtures. But where should all this code live? I created a cookbook named Feign. According to Webster's dictionary, feign means to give the false appearance of. And this is perfect for what we're trying to do. So I've taken that event handler and put it into the recipe feign NFS mount. And here's the YAML that you can see where I've added that recipe to the run list. So changes to support testing are limited to the testing facility, and it's not littered throughout the code and making it cluttered. And lo and behold, the recipe converges. As you can see, the mount action is skipped and only the enable action is taken. For most hardware specific recipes, it means that it is only applicable to run on that particular hardware, not that it can only run on that hardware. There's a big distinction there, and this is what we leverage. Let's look at a recipe that sets up the Dell repo and installs service packages. There is nothing here that requires it to be run on a Dell server. In fact, it converges and verifies under Dokken just fine. However, you probably don't have separate run lists for Dell hardware versus HP. You probably have a default recipe that has a conditional logic based on the hardware platform you are, including different recipes. And if you run that under Dokken, as expected, nothing is converged because it's not Dell. So, but you really want to verify your cookbook and verify that your conditional logic is correct. I created a Dell recipe in the Feign cookbook that sets the OHI attributes such that it appears to be running on Dell hardware. We cannot use the kitchen YAML attributes because they are at the normal precedence level, and OHI populates at the automatic level, which has higher precedence. So we have to use a recipe. And as you can see, we've added that recipe to the run list in the kitchen YAML. Now, the other thing that putting it into a separate recipe is that you can reuse that easily by just saying, hey, it's Dell, instead of having to remember how it's being set and how you're accessing it from your conditionals. You can just easily set it up. Likewise, I've created a Feign HP recipe to make it appear that it's running on HP hardware. So one could write tests for the HP suite to actually test the negative testing, which is saying that as you can see, it has, you're expecting those packages to not be installed when you're running on HP hardware. Likewise, there's model-based logic. I mean, different settings may be required on different generations of hardware. Different models have different rate controllers, thus requiring different monitoring setup. Any place that you have conditionals, you should have tests that validate that logic and the generated config. Sometimes the logic is location-based. Have something like this, and somebody may say, well, it can only test this in AWS. Again, I say wrong. You can create recipes to make it appear that the node is in a particular region, and then be able to verify the different test suites for different locations and verify the logic works in those. And then there are test environment limitations. Docker for Mac lacks AutoFS support. If you want to test, an AutoFS entry, what you're really wanting to do at a higher level is test that the entry is actually added to Etsy auto.nfs. But that resource starts the AutoFS service or restarts it when an entry is added. So we need to mock the AutoFS service. I override the action scripts with bin true for AutoFS such that every service action is essentially a no-op. This allows the service to be restarted and do nothing, and just so that we can go back and be able to test that the entries are added to Etsy auto.nfs. I've also done a similar strategy to fake out hardware specific services such as IPMI drivers. Now, if you look at this one, I'm going to go against what I said in the past. There are some cases, such as utility cookbooks, where including a Feign recipe for every cookbook that includes that utility cookbook is cumbersome. So a cookbook may include a cookbook, including another cookbook, and down there you have the requirement of AutoFS. So as you start bubbling up the layers, it becomes difficult to keep remembering to do those, that you'd have to add support for that in your testing. So include that in your utility cookbook. Whatever you can do to lower the barrier of entry to test is worth it. If you make it simple, there is no excuse for people not to test. There are times when resources or recipes make HTTP calls to perform actions or grab status. Instead of adding conditionals in the mainline code, you can use WebMock. And if you've never taken a look at WebMock for doing things, I highly recommend it. It is really powerful. In this example, I stub a post to HTTP coffee.example.com. This allows the cookbook to converge. And for web mocks, I usually include them in the mainline code in the recipe, such that the code doing it and the mock is right there, so that it's easier to keep the mock in sync. Because if you have mocks separate, a lot of times when you come around to testing it, you may change your mainline logic, and then you forget that you have to go someplace else to update the mock to do it, to keep them in sync. So I have just found in my experience, by keeping those together, it just makes it easier to keep them working together. Now, this one example, we're just always returning 200, but there may be cases where you want to be able to test different results, and it has different behaviors on there. So you can set up different test suites to go through success and failure cases, and making sure that your code reacts properly to the different results from those web requests. In closing, I'd like to wax philosophically. The alarm clock was designed to sound the alarm at the specified time. You purchased the clock to wake you up at 7:30. If you shut off the alarm and fall back asleep, is the design of the clock flawed? No. The alarm clock did what it was supposed to do. And I'm pretty certain that quality control at the alarm clock factory just tests whether the alarm goes off. They don't put it in a room with sleeping people to see if it actually wakes them up. As I have shown, with a little effort, you can test quote unquote hardware cookbooks, because in the end, it is just all software. Remember to trust the lower levels and just test your layer. All the source code from this presentation is on GitHub. My blog is novels.github.io, and I will post links there for all of the references that I have in this presentation. Thank you, and have a great ChefConf.
Oh, that was great. Thank you very much, Joe. That's some excellent tidbits about how to test some cookbooks. I never thought about the AutoFS stuff with macOS not being able to mount. That was quite interesting there. So quite a nice little tidbit. I actually started on Chef 10, so seeing somebody who came and used Chef before Chef 10 was this was the early pretty high iteration days where we're still trying to figure out what Chef even looked like, and figuring out that turns out I think I had the same bug actually. Like I think I started using Chef as we were fixing that as a community with the Rubies and that kind of stuff. So I was really glad that that's now fixed, and it's just no longer a problem, which just makes everything much easier.
One thing that I have found with being in the community so long is that I used to dread ChefConf because inevitably Adam Jacob would get up on stage and talk about a new feature that I just spent the last 6 months implementing something similar. And so I was like, oh, I wish I would have known those sorts of things. But yeah, it was a high iteration. And a lot of other things is like, we'll have people come in and say, well, why aren't you using this feature of Chef? And I'm like, that's because it didn't exist in 2012 when this code was written. and sort of things. And so, yeah, so it has, you have history, but it also has things on, things on there.
It's got an interesting question from Lance here. So how do you think you can mock different architectures? He can easily do it in Chef spec, but running it in Kitchen really requires it to do it on the actual hardware.
So for different hardware, so you can do what I've done is for different hardware models. Are speaking of different architectures? So if you're talking about different architectures, where if you're running on Test Kitchen, you want to say, mock out, it's running on AIX or something like that. That one would be harder to do. It's easier if you're on the same sort of platform. I mean, we're just all of our stuff is just based on, Intel hardware running, Linux. So it's easy to go through those iterations of being able to take a recipe and then load the or override the OHI attributes that are there. So what I have done for the different models is actually run an OHI on the particular hardware and then grabbed out the DMI section and then put it in there. So then it actually just merges it in there. So you have all of the different fields, because you don't know if you're going to be, if some of the recipes that people write, are they going to be based on whether it's in the case where it was the system manufacturer, or if it's the BIOS manufacturer. There's different fields where people can be looking at things. So if you just grab the whole data, DMI data, you can do that and then pull that into the OHI attributes and then make it look like the different pieces of hardware. I've actually done that. One of the things that I found on our Jenkins servers is that the DMI data is actually coming from the hardware that it's running on, So there have been times when we're actually testing for, well, what happens if you're running on a VM? And so I actually have to have a recipe there that gets loaded to simulate a VM by clearing out the attributes for certain things that get sort of like, percolate up from the hardware that it's running on.
So I think that's where the secret of FauxHire really comes in, isn't it? So, well, PowerPC 64 doesn't have DMI, these kinds of things, and then virtual machines don't have some of the OI attributes even set. So iHire is where information sort of bubbles up into, and so we pick up automatic attributes from. That's where FauxHire really comes in, and we can set those, so we can run FauxHire on different platforms and then load that in, I guess, and override those attributes. That'd be a way of doing it, I would expect.
Right. I think that some of the cases, like if you're running on things, there are lower level things that that maybe don't get out on conditionals, that maybe are saying down at the Ruby level that there's differences of doing things where what you could mock out isn't going to happen. You can start to think about system libraries and things like that, where it's expecting things coming from one place and versus another. So for example, say you had something in a low level module, I don't know, like the Ruby Etsy module, and it would come from that's pulling some of the data, and it may be on AIX. It comes from different locations, and so those sorts of things, you could set up files to be in different locations, but is it going to, because it's based on the Ruby that's compiled for the platform you're running on, even if you lay down the files in var smet, is it going to reference those things?
Exactly. Yeah, I think I guess the long and the short of that is there's a limitation as to how much you can mock, isn't there?
There is.
Yeah.
But based on your model, if you have different hardware models, that's a that was kind of the idea where this sprung out of, is being able to simulate different different models of hardware on there of the same platform, but that you have different things like differences between LSI RAID controllers versus the Dell RAID controllers, or SAS versus SATA disks. If you're doing differences in monitoring and things like that, you simulate those things easily. That's what I was, a lot of the stuff came out of.
I guess where so architecture is just you can't really be on a x86 64 architecture and then be like, we're just going to pretend for a second we're in a PowerPC architecture, because the CPUs are just entirely different, and faking them out without virtual machines is pretty hard. Well,
I mean, you can do these things in Chef spec. However, Chef spec, it just sets up the resource collection, and you can test whether things are there or not. I actually have on a blog post from a few years ago about testing hardware platforms with Chef spec, of doing a similar thing with Chef spec, and then you can say, okay, here's where the data is, and not. And Chef spec was great, but it didn't do the actual down to the converge on the platforms, and sometimes you want that extra step that it gives you, that extra step of validation of there. It's sort of an idea of that. With Chef spec, it says, here's the resource collection, but it may not be, and you're testing of are things in the resource collection, but the resource collection may be invalid for the platform. I
think I've dropped your blog post in the chat if anyone's going to see that. So testing a hardware specific recipes with Chef spec is the one you're talking about there. That's pretty cool.
Yeah, all of these times we've come out of just doing it, of people not testing, and and so making the developer experience more delightful. and actually kind of sometimes saying, making it such that, as I stated, he goes, if you make it so simple to test, there's no excuse not to do testing with it. And you should always test whatever you do before it goes out.
That's a great place to close out, I think. If anyone's got any more questions, throw them in the chat. However, I'm going to assume the quietness is amazement, quite frankly. Thank you very much, Joe, for giving us a run through your hardware cookbooks today. And everyone else, have a great ChefConf Online 2021.